Good day, this is the video submission of Practical 5 for EEE3096S. This is group 28, so that includes myself, Veshalin, Naidoo, and my partner Tinashe, Dzimbanhete. So the purpose of our prac was to sample data from an ADC. The data was being fed into the ADC from a temperature sensor. So we basically just wanted to print out the value that we were reading from the temperature sensor and the temperature at different time sampling rates, so from 10 to 5 to 1. And I'll now hand over to my partner who will go through the work division and then through his section.
I'm Tinashe Dzimbanhete. I was the one covering mainly the hardware section, planning on where the wires go and setting up the hardware section and setting up our schematic for the Pi, while my partner was in charge mostly of the code and the flowchart and running that. And then we were blending each and every section, like we were heads, but we were still blending in each and every section. In this video, I want to explain our schematic. So our schematic, as you can see from the screen, we've got our Raspberry Pi here with 20 pins in each side. I've only marked the pins that I used to save time, for saving time's sake. And from the work packet 5 PDF, we then learn on where each pin goes and connects to the MCP 3008 IC. So it's fairly, after doing the schematic in Altium, it's fairly simple to wire up. We looked for another GPIO pin, which is probably GPIO pin 21, to put our push button here with the pull down resistor, and our temperature sensor with our external temperature sensor is connected to channel 1 of the MCP and ground and 3.3 of the Pi. And this is basically how our schematic is looking, and that's what we use to set up the circuit. So like this is the actual physical appearance of the circuit that we wired together with some alterations on this side. I'm SSHing my Pi through Wi-Fi, and that's why it's connected to the power. And as you can see there, that's where our push button is that controls the sampling time between 10, 5, and 1 second. And then we used rails on the breadboard in our design, so that we make like the wire considerations simpler and all the wire connections are there.
Hello again. So I'm first just going to go through a flow chart of the logic of the program, then take you through the actual code, and then finally the execution of it. So at the beginning, we're just going to start the program, import all our libraries, and initialize the program and the threading. So the threading is what we're going to use to make it run again at certain time intervals. So we're going to read our ACD values and our convert that to the temperature values and then print all of that. And whenever the button was pressed, it's going to signal an interrupt to change our sample rate from 10 to 5 and then to 1 and then back to 10. And when we reach 60 seconds, the program will stop. And that's basically it. Okay, so I'm just going to go through the code. I opened it up in Notepad++, just because it's a little bit easier to read through here. Yeah, so all our imports, and then I define our sample time and just the initial time value. So we can use that to later work out our runtime. And then this is just setting up the pin. We added an event so that whenever there's a falling edge, and when the button is, it's going to call back this method. And I just added a bounce time of 200 just to give us some time after the button's pressed, just for values to reach whatever they should. Yeah, so when the button's pressed, if it's 10, it goes to 5. If it's 5, it goes to 1. 1, it goes back to 10. That's pretty self-explanatory. And then just for our temperature, so when the temperature, the runtime is less than 60 seconds, we're going to create a thread first. And yeah, so we're going to start that thread, and it's going to run at our sample rate, which will be changed by the button and be defined in our global variables. And then we can work out our time now, minus our runtime, convert that to seconds, and then just format that. And printing that will get us our time. Also, and then we're going to print out our channel value. So we define the channel up on top there. And the temperature we can work out using our channel voltage, and then just converting that. So that's basically the whole program. Quite simple. Cool. So now I'm just going to run through the program and go through how it executes. So we see that it's outputting our runtime, our temperature reading, and then the temperature. I made that 2 decimal places. And if I press this button here, we should switch from a sample rate of 10 seconds to a sample rate of 5 seconds now. So there we see we switched to 5 seconds, and I'm just going to hold our temperature sensor now just to increase that temperature. You can see it going up now. Just make it 1 second for the sample rate. We'll let go, and our temperature should come back down. Then I'm going to switch back to 10 seconds for the sample rate. And we see that change occurring now, and that's basically our program.